Assalamu alaikum. I'm Mohammad Saifuddin Shobham. The last 3 digit of my ID is 956. Today my presentation topic is Introduction to Microcontroller. Today we will learn about the definition of microcontroller and the types of microcontroller. A microcontroller is an integrated circuit that can be programmed to perform a set of functions to control a collection of electronic devices. A self-contained system in which a processor, support, memory, and input-output are all contained in a single package. Here are some pictures of microcontroller. The types of microcontroller are on different bases. Like on the basis of bits, it is 4, 8, 16, and 32 bits. On the basis of memory or devices, it is embedded or external. On the other hand, in instruction set, it is CISC and RISC. On the basis of memory architecture, it is Princeton and Harvard. 4-bit microcontrollers performs arithmetic and logical operations on a nibble at an instruction. It has internal bus width which is only 4-bit. It is small in size, minimum pin count, and low cost controllers. It is low power consumption and used for low-end applications like LED and LCD display. On the other hand, 8-bit microcontrollers performs its arithmetic and logical operations on a byte. It has internal bus width of 8-bit. Example of 8-bit microcontroller is Intel 8051 family. 16-bit microcontrollers performs its arithmetic and logical operations on a word or 16-bit at an instruction. Its internal bus width is 16-bit. It has enhanced performance, computing capability, and precision as compared to the 8-bit microcontrollers. At last, the 30-bit microcontrollers performs arithmetic and logical operations on a double word or 32 bits per instruction. Its bus width is 32-bit. It is much more enhanced performance, computing capability with greater precision as compared to the 16-bit microcontrollers. The example of 32-bit microcontrollers is Intel 80960 family. Now, the embedded microcontrollers. An embedded system has a microcontroller unit that has all the functional blocks available on the same chip. Example, 8051 having program and data memory, input-output ports, serial communication, counters and timers, and interrupt control logic on the same chip. This is a picture of embedded microcontroller. External memory microcontroller. An external system has a microcontroller unit that does not have all the functional blocks available on a chip. All or part of the memory units are externally interfaced using an interfacing circuit called the glue circuit. Example is Intel 8031 microcontroller, which has no program memory on the chip. This is an example of external memory microcontroller. Here we can see the memory interface is externally connected in the IC. The CISC microcontroller. It has an instruction set that supports many addressing modes for the arithmetic and logical instructions, data transfer, and memory access instruction. Example is Intel 8096 family. The RISC microcontrollers. It contains an instruction set that supports fewer addressing modes for the arithmetic and logical instructions and for the data transfer instructions. It has a smaller chip and pin count. It is very low in terms of power consumption. The von Neumann architecture. It has a single bus that is used to fetch both the instruction and data. Program instructions and data are stored in a common main memory. When such a controller addresses main memory, it first fetches an instruction and then it fetches the data to support the instructions. It simplifies the microcontroller design because only one memory is accessed. The weakness is that two separate fetches can slow up the controller's operation. Here is the architecture block diagram of von Neumann. Here we can see in the left there is a program ROM, a variable RAM, a stack RAM, which is connected with the memory interface unit with the data bus, address bus, and control bus. The memory interface unit has an instruction decoder and it is connected with processor and built-in registers. Harvard architecture. It has separated data bus and instruction bus. Its execution occur in parallel. It is much faster execution than the von Neumann architecture, but its design is more complex. As we can see, the Harvard architecture block diagram, we can see in the left side we have a control space. In it, we have a programmable ROM, which is connected with the instruction decoder through data bus, address bus, and control bus. The instruction decoder is connected with the PC stack. And on the right side, we can see a register space, which is connected with the processor and register interface through data, address, and control bus. That's all for today. Thank you for your attention. Assalamu alaikum.